Hello children, from chapter number 15 probability, we have already started solving the sums from exercise 15.1 and moving ahead with the next sum. This is question number 16 from exercise 15.1. The sum is 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether it's in proper condition or defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. Now let's find out total number of pens. So we are given that total number of pens is equal to total number of defective pens plus total number of good pens. Now the number of pens which are defective are 12, and these 12 pens are mixed with the good ones, and the good pens are 132. So total number of pens are 144. Now what is asked? If one pen is taken out at random from 144 pens, what is the probability that the pen is a good pen? So we'll just make use of our formula and find this probability. So we'll write down probability of getting a good pen is equal to number of good pens upon total number of pens. Now total number of good pens are 132, which is given in the sum. So we will write this 132 upon total number of pens are 144. And if you reduce it to lower term, we get the answer as 11 upon 12. So probability of getting a good pen out of total 144 pens is 11 upon 12. Okay. So the next sum now. Next sum is a lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from a lot. What is the probability that this bulb is defective? Now see how many bulbs are given to us. We have been given that there are 20 bulbs, and out of these 20 bulbs 4 are defective. So 20 bulbs, let's mark the defective bulbs first, because we are given that there are 4 defective bulbs. So 1, 2, 3 and 4, these are the 4 defective bulbs. We are asked what is the probability that the bulb is defective when you take out one bulb at random. What is the probability that it is a defective bulb? So let's make use of the formula that probability of getting a defective bulb is equal to number of defective bulbs in the given lot upon total number of bulbs. Now we have been given that there are 4 defective bulbs. So 4 upon 20. If you reduce it to lower term, we get the answer as 1 upon 5. And this is the probability of getting a defective bulb. Now the second part of the sum is suppose the bulb drawn is not defective and is not replaced. We have been given that there are 20 bulbs, and from this 20 bulbs one bulb is taken out and that is not defective and it is kept aside now. Now one bulb is drawn at random from the rest. What is the probability that the bulb is not defective? See children, at the first step what is done? From the 20 bulbs, one bulb is taken and they said it is not defective and that bulb is been kept aside. Then how many bulbs will be there with us then? There will be 19 bulbs because one bulb is taken aside. Now from this 19 bulb, they are asking what is the probability that the bulb is not defective. Now in the first case we studied that there are 4 defective bulbs in this 20 lot. Okay, so from the remaining 19 bulbs, let's first take out the 4 bulbs which are defective. So number of non-defective bulbs will be equal to 19 minus 4, and that is 15. Alright. Now we are asked, what is the probability that the bulb taken out is non-defective? So our formula will be probability of getting a non-defective bulb is equal to number of non-defective bulbs upon total number of bulbs. Now we have calculated that out of 19, if we take out 4 defective bulbs, the non-defective bulbs will be 15. So substituting the values, we get 15 upon 19, and this is the probability of getting a non-defective bulb. Alright, so simple sum, but little you have to understand. Then the next is, a child has a die whose 6 faces shows the letters as given below. And the letters are A, B, C, D, E and again A. The die is thrown once. What is the probability of getting A? Children, this is question number 19 from exercise 15.1. A die is thrown and instead of 1, 2, 3, 4, 5, 6 on the die, some letters are written. And these letters are A, B, C, D, E and again A. We have been asked what is the probability of getting A. Now total number of faces on the die are 6. If you see where A is flashing for 2 times. So number of faces having A on it is equal to 2. And so probability of getting A is equal to number of faces having letter A upon total number of faces on the die. And we have been calculated that number of faces having A is equal to 2. So you will write 2 upon 6. You can reduce it to lower terms and it is 1 by 3. So probability of getting A is 1 upon 3. Now the second part of the sum is, what is the probability of getting D? Now if you see all the faces, you can just check out that D comes once there. So number of faces having D on it is 1. So our formula will change now. Probability of getting D is equal to number of faces having D upon total number of faces on the die. And number of faces having D is only 1. So your answer is 1 upon 6. That is the probability of getting D. Alright? Okay, moving ahead to the next sum. Our next sum is question number 20. Question is, suppose you drop a die at random on a rectangular region, which is shown in the figure. Please have a look at the figure. What is the probability that it will land inside the circle with diameter 1 meter? So little different sum, children, but very interesting. A die is thrown and it is thrown in a rectangular region. We have been asked what is the probability that the die will go or will fall inside the circle. Now here we will consider area of both the geometrical figures to find the probability. So let's first write down the measurements. We have been given a circle with diameter 1 meter. So its radius is equal to 1 by 2 meter. Then we will first find out the area of a rectangle, because in this sum our sample space or total number of total number of outcomes that we have to consider as area of a rectangle. So we will write the area of rectangle. The purple color is a rectangle with length and breadth given to us. So we will write area of rectangle is equal to length into breadth. Substitute the values into this formula. 3 into 2, that is 6 meter square. Now let's find the area of the circle. Area of the circle inside the rectangle is equal to pi r square. Substitute the values. Pi into radius is 1 by 2. So 1 by 2 the whole square. So your answer is pi into 1 upon 4 meters square. So now let's use our formula. Probability that the die will fall inside the circle is equal to area of circle upon area of rectangle. Now area of circle is our favorable outcome and area of rectangle is our total number of outcomes. Alright, so let's substitute the values. Area of circle we have already calculated, that is pi into 1 upon 4, and area of a rectangle is 6, so upon 6. Simplify this, you get pi upon 6 multiplied by 4, and that is equal to pi upon 24. So the probability that the die will land inside the circle is pi upon 24. Alright children, so this is a different kind of a sum. You can consider this sum as a hot sum, that is higher order thinking level sum, and such sums may come in the exam. So prepare such type of sums. Moving ahead to the next sum. This is question number 22 from exercise 15.1 and pretty interesting sum. Have a look at this. Two dice, one blue and one grey, are thrown at the same time. Write down all the possible outcomes and complete the following table. So you have been given a table and you have to complete this table. Two dice are thrown together. So when you throw two dice together, what are the possible outcomes here? You have been given that one die is blue in color and the other die is grey in color. And when you throw these two dice together, what are the possible outcomes? So have a look at this. This table will give you an idea. When you see the horizontal first line, the red color numbers 1, 2, 3, 4, 5, 6, these are the outcomes for the grey die. And the vertical numbers 1, 2, 3, 4, 5, 6 in red color, these are the outcomes for the blue die. And when you are throwing both the dice together, then what are the outcomes we will get? 1, 1. Maybe both the die may have 1, 1. Second possibility is 1 and the other die may have 2. Third possibility is first die will still have 1 and the second die will have 3. Then 1, 4, 1, 5 and 1, 6. Then second possibility is first die may have 2 at the top and the grey die will have 1 at the top. So 2, 1, 2, 2, 2, 3, 2, 4, 2, 5 and 2, 6. And in this way you can complete the table and you will find that the total possible outcomes are 36. So when you throw two dice together, total number of favorable outcomes is equal to 36. Alright, now have a look at this table. First horizontal row, sum of the two dice is 2. Now if you look at the outcomes which we have written there, sum of the two die, when you throw two dice together, sum of the outcome which you get at the top of the die is equal to 2. So this you can see, this is the first favorable outcome 1, 1. If you add it, the addition is 2. So total number of favorable outcome, the sum is equal to 2 is only 1 and the probability will be 1 upon total number of outcomes, and total number of outcomes are 36. So 1 upon 36. Now if you see the second blank, what is asked? Sum of the two die is 3. Now you check out the sample space wherein you have written all the possible combination. Where do you see that the sum on the top of the die is 3? Can you see this horizontal line here, the slant line, purple color? So if you add these two outcomes, the addition comes to 3. So how many outcomes are there? Favorable outcomes, these are 2. And if I make use of the formula, probability of getting the number whose sum is 3 is equal to favorable outcome upon total number of outcome. Your favorable outcomes are 2, 2 upon 36. So see what you get. 2 by 36 is equal to 1 upon 18. Next blank is, what is the probability that the sum of the numbers on the two dice is equal to 4? Now have a look at the table once again. Where do you get the sum as 4? Can you see this yellow color line? If you add this outcomes, the addition is 4. So probability is 3 upon 36, and 3 upon 36 is 1 by 12. Next blank, sum of the two numbers on the dice is 5. Let's find out. If you just check out this blue color line which is passing through 4 favorable outcomes, the addition of those outcomes is equal to 5. So your answer is 4 upon 36, and 4 by 36 is 1 upon 9. Next is, what is the probability that the sum on the dice is equal to 6? Let's find out here in the sample space where the sum of the numbers on the top of the dice is equal to 6. Have a look at this line. The line passes through 5 favorable outcomes. So probability is 5 upon 36. Next, sum of the two dice, sum of the numbers on the two dice is equal to 7. So let's first find out our favorable outcomes. If you see this blue line, and it is passing through how many favorable outcomes? 6. Yes. And if you add the sum of the numbers on the 6 favorable outcomes, the addition is coming equal to 7. So probability is 6 upon 36, that is 1 upon 6. Then sum of the numbers on the die is equal to 8. That's already given to us, so we will not find that. Next is, sum of the numbers on the two die is equal to 9. So this green line, if you see all these favorable outcomes, if you add the numbers on the top of the two dice, addition is 9, and so the probability is 4 upon 36, and that is 1 upon 9. The next is, what is the probability that sum of the numbers on the top of the dice is equal to 10? Check out this. There are 3 favorable outcomes. So 3 upon 36, which is equal to 1 upon 12. Next is, what is the probability that the sum of the numbers on the top of the dice is equal to 11? These are the 2 favorable outcomes. So the probability is 2 upon 36, which is 1 upon 18, right? And the last, sum of the numbers on both the die is equal to 12, and that is only one outcome, that is 6, 6. So 1 upon 36 is the probability of getting the sum of the numbers on the top of the die as 12. Alright, so this is how you have to find out. Very interesting sum. Total outcomes here, when you throw two dice together, total number of outcomes is equal to 36. And based on that, you had this table to fill up and solve the sum. Right? With this, now there are 2 sums for you as homework. Question number 18 and question number 21 from exercise 15.1 we have not solved. These 2 sums you have to try at home and try finding the answer. In question number 18, you will make use of arithmetic progression to solve this sum. If you wish, you can make use of AP, otherwise you can solve it the method of your own. And question 21 is also very simple. Try both the sums and solve it in your classwork. So that's it for today's video lesson. See you with the remaining sums in the next video lesson. Till then, bye and take care.